Hello, guys. Last class you completed the lab where you compared how the lamp on the soil changed temperature differently than the lamp on the water. You just completed a simulation right now about how um, different materials change temperature at different rates. And all of this is pointing us to understanding about what specific heat is and how it affects climate. So, what is specific heat? Feel free to fill in the notes as we go over it. At different points, I'm going to say pause the video at those points, complete what I tell you to complete, and then restart the video. So, what is specific heat? Specific heat is the amount of heat required to raise the temperature of 1 gram of a substance 1 degree Celsius. A very precise definition this is saying is just saying how much heat does the material require to get hotter? How much heat does it need to get hotter? Different things heat up at different rates. This is something you've probably noticed. Different things heat up at different rates. Think about this. When you take a pizza out of the oven, you're going to notice and you're waiting for it to cool down, right? You're going to notice that when you bite into the pizza that the sauce is often a lot hotter than the crust is. The reason for this is specific heat. So let's keep learning about it, okay? In other words, the higher the specific heat of a substance, something that has a higher specific heat requires more energy to heat it up. So if something has a higher specific heat, you're going to have to heat it up more in order to get it hot. So guys, you're going to see this picture in your notes as well. I want you to pause the video and in the orange box in your notes, write what this picture is showing. Pause now. Okay, so you should have filled in the orange box. What is this picture showing? It's showing that you see the flame under the same flame, same match with the flames under both the gold bar and the block of water. However, the same flame under the block of gold causes the gold to grow to a temperature of around 90 degrees Celsius, or heat up 10 degrees Celsius, where the same match under a block of water, or a container of water, causes it to heat up to just over 20 degrees Celsius. So clearly, just because the same heat is being applied to two different materials does not mean they're heating up to the same amount. Water has a very, very high specific heat. So water is really unique in that water requires a lot of energy to increase in temperature. So remember, before you answer these questions, before you pause the video and answer these questions, remember, materials with higher specific heats take longer to heat up. Okay, so pause the video, and with that knowledge, answer these questions. If you feel like you can't answer these questions, look back at your notes, what you just filled in, and you should be able to answer the questions. So pause the video now to answer the questions. Okay, you should be done answering the questions. We're going to move on to the next part. So how does water's specific heat affect climate? So what is like the fact that water has really high specific heat? In other words, water takes a lot of energy to heat up. What does that have to do with climate? That's what we're learning about, right? We're learning about weather and climate. So I'm going to pull up this video. As we watch the video, I want you to pay attention.
My team and I always had trouble managing our tasks until one of my colleagues found Monday.com. You can see the task owner.
Another factor that affects the climate of an area is whether that area or region is near a large body of water. Now, we're not talking about a small little lake, but something huge like the Gulf of Mexico, one of the oceans, or even Lake Ontario slightly as well. So imagine we have two locations, two cities. So here's the land, and here's the large body of water over here. So some places are inland cities, so they're really far away. Let's think like Nebraska or Kansas. So here is city A, and we'll have city B, which is right on the water, and we're talking about maybe Washington, D.C. or Miami. So one is an inland location, city A. The other is a coastal city, city B. Because of water's high specific heat, it is going to take longer for that water to heat up. It's also going to take longer for that water to cool down. So you remember from the front page of your reference tables, liquid water has a specific heat of over 4 joules per gram. Yet land, which is made out of rock, maybe some basalt and granite, that has a specific heat of less than 1 joule per gram. So that land is going to heat up a lot faster than the water is going to heat up. So if we looked at the temperatures of the cities over a year, we might see that City A, the hottest temperature at City A maybe gets up to 95 degrees. So let's say that's the hottest it gets, or what does that say, 96? Let's say the hottest temperature gets up to 96 degrees at City A. Yet in the wintertime, the coldest temperature found at City A drops all the way down to, let's say, there is 4 degrees. So the coldest gets 4 degrees Fahrenheit. The range, or the difference between them, is quite large. So we have a large range in temperature. From wintertime coldest temperature to the summertime hottest temperature is a 92-degree range. But since City B is near the water, near a large body of water, the water itself is going to heat up more slowly in the summertime. And since City B is near that water, it's going to have that cooling effect as well. And that temperature is not going to get up to 96. Maybe that summertime temperature is going to get up to around there. What do we got? 85 degrees. So for City B, the hottest it's going to get is about 85 degrees Fahrenheit. In the wintertime...
Pause. So why doesn't City B get as hot as City A? The same latitude, same altitude, because it's close to water. And the water that's right by it takes longer to warm up, right? So it's going to make this city be a lot cooler in the summer. But there's more than just that.
The water has a lot of energy in it, and it's going to take a long time to cool down. So it's not going to cool down as quickly as the land does. So its temperature might drop down to about 12 degrees in the wintertime. You'll notice that we have a much lower temperature range. Now we have a 73-degree range. So if you live near a large body of water, what happens is the large body of water heats up slower than the land, it cools down slower than the land, and it sets up that those inland locations have a larger temperature range than the coastal locations. If you're near a large body of water, you have a smaller temperature range. Your summer times are a little bit cooler. Your winter times are a little bit warmer. If you haven't already, go ahead and copy this down into your notes.
You actually don't have that in your notes. That's okay. But what we learned from that, how does water-specific heat affect climate? How does the fact that water is unique in that it takes a long time to heat up or a long time to cool down, how does that affect climate? Well, if you live near water, water moderates the temperature in areas near ocean. Moderating means instead of being extremely hot or extremely cold, it makes it more in the middle. Areas near water have colder summers and warmer winters than areas far from water. That is in your notes, so make sure to write that down. In other words, the average range in temperatures is smaller in areas near water. Remember, because of water-specific heat, not only does it take water longer to heat up, it also takes water longer to cool down. So no matter if you live near water, you're going to have less of the extremes and more of a moderate temperature, like what we saw in the example with Oregon and South Dakota the other day, right? Oregon's low was 35, its high was 65 degrees, whereas South Dakota's low was 25 and its high was 70. So South Dakota got colder in the winter, but also got a lot hotter in the summer because it wasn't near water. So what I want you to do, guys, you're going to answer these two questions in your notes. If you feel like you don't understand how to answer these, I want you to go back and listen to that part of the video we just watched and make sure you really are understanding it, really getting it before you try answering these incomplete sentences. Make sure for both questions, guys, you answer the why. After you've answered both questions, if you really need help, talk to your partner, that's okay. After you've answered both questions and you feel comfortable with the answers, go ahead and submit them or turn it in onto Google Classroom so I can grade it this weekend. If you have any questions, once again, feel free to give me an email, shoot me an email, and you'll be all set. Thanks so much, guys, and I will talk to you soon.